Okay, good afternoon, everyone. I hope you had a good spring break. You got to relax a little and ready for the second part of the semester. Okay, did you guys have the chance to do your homework? Yes or no? Okay, do you have any questions? Yes, all right, any questions about any problems from the homework? All right, anybody else? Okay. As usual, when I grade a quiz, I look what the class did and I like to comment. Now, you guys have comments on your quizzes. Make sure you read them. But I would like to always comment on what the whole class had difficulties with. So in the quiz that I gave you, the first part was about the piecewise defined function. And the second part was about composition. The composition part you guys did fine, so I won't really talk about it. You just check your mistakes. But this part, it was kind of disappointing. It was not very good. So I will go over this part, hopefully for the last time before your exam, because this will be on your exam. And then I proceed to every questions you guys have, right? So before I do that, let me remind you this basic stuff and where you guys did a mistake. So in the equation of a line, So I will point out the mistake you did when you were applying your formula. All right. So suppose we have a line. We'll go that very quickly. And you have 2 points on the line. So we call them, let us say x2, y2, x1, y1, okay? And then the slope is the rise over the run. So the rise or the change in y is the y2 minus y1, and this is x2 minus x1, okay? Then the slope is the ratio between those two. So that was the slope. So it's y2 minus y1 over x2 minus x1. All right, the mistake that I like to do. Some students, first mistake, are still doing the change of x of the change in y. And that's absolutely wrong. It's always the change of y over change in x. So mistake number one is a lot of students are switching them, which is not correct. The second mistake that's occurring is that if you put y2 in here, you have to put x2 in here. It means this is the first point, and that's the second point. You don't mix the order. It means you don't put y2 minus y1 over x1 minus x2. That's wrong. That's not the definition of the slope. So this is the mistake that you guys are doing when you're computing the slope. Now in the equation, wasn't bad, so you're applying the equation correctly. So your mistake was most of the time in the slope. So the equation, you can either use the point slope. You pick one of the point, you use the point slope. You have to remember those two should go together. Or you can use the slope intercept, y equal mx plus b. So that's how to find the equation. Now, when you find the equation, the b is nothing more than the y value when x is 0. Means the b is right there. So if you find the equation and you get a b, you find b, ask yourself, does my b make sense? It means, is the b I found actually is when the line intersect the x-axis? Is this value here? So you can make sense out of things, right? And what's the meaning of the equation? Okay, the meaning of the equation is the following. The goal of the equation is to give us this rule, this formula, if you want, so that if I take any point here, if I know what the x is, the goal of this, that gives me the y. So it's giving me the formula. So if I know the x, the formula, this one will give me the y. So that's the benefit of the equation. That's really what it does to me. So so let us see, for example, and the example is part of your quiz. So suppose I give you the following example. Okay, the graph of a function f is given. So I'm going to give you the graph of a function f is given. Now my question is, find the formula for f. F of x. So before I go back to your quiz, I will do a little piece. So this time I'm going to give you the graph, which is going to be a straight line. And this is my graph. I'm going to give you 2 points. This point, 0, -3. And another point right here, 2, 3. Okay. So that's the graph of my function. Finding a formula means find the rule. That if I know what, that's what it means. If I know what x is, the rule should give me what f of x. So this is basically the same thing. So this is equivalent to us find the equation of the line in this problem. Of the line. So very easily, what's my slope here? So I have to take the 2 points and I have to do it correctly. My 2 points are 0, -3, and my other point is 2, 3. So my slope, and we do it correctly. Change of y, 3 minus -3. And then if I pick 3 here, this should be the 2 minus 0, which is going to give me a 3. The slope has to be positive because my line is rising. So the equation now is 3x plus b. But in this particular problem, b is -3 because for x equal to 0, y is -3. If I plug in -3 here, 0 here, I get b. B equal to -3. So in this particular problem, I have b of the back. And this will give me my equation. So it means my function f of x is 3x -3. What's the benefit? One more time. What's the benefit? What's the benefit of this formula? Who can tell me what's the benefit? I don't want to be talking to myself.
That you can apply it to any point on the line and it should, like, or any coordinate, and it should give you the same kind of answer you're expecting. Dang, I had it in my head.
Okay, it means if I have a point here, x, whatever this point here, let us say this is 5, okay, and I don't have a grid. So let us assume, like in this, I don't have a grid. So I'm going to ask yourself, okay, what this value should be? The formula will give it to you. Tell you, okay, if you pick this 5, 3 times 5, 15, 15 minus 3, this should be a 12. So that's really what the formula does for us in this particular scenario. And Leia was, I think it's Leia, whatever. The student was kind of correct. So now I'll go back to your quiz and finish it very quickly. Okay. So in your quiz, you have this function and you want a formula for it. It means you want this rule so that if I gave you the graph of it, but now I want the rule that if I know the x, the rule should give you the y correctly. So in this picture, for example, you know, if -4, you know what's the y. But if I take something like -1, this become a little bit, you know, I don't know what this is. Is it 3.5? Is it 3.6? So I really don't know at this stage. There is a limit to how much the graph is telling me. The formula give me the values, will give me the values correctly. So how are we going to find the formula? The problem here that I don't have one line. I have 3 of them. And to find the formula, if my x is from here to here, up to -1, if I know x, I need the equation of this line to find the y. If I am from here to here, I need the equation of this line to find the output. And after that, I need the equation of this line. So we will do them one by one, and then I'm gonna put them together. So I'm gonna find L1, equation of L1, which is most of you, for some bizarre reason, almost, not all of you, but a lot of you got it wrong. I mean, it's like bizarre. So I need 2 points. You pick 2 good points. 2 good points. I don't have the intercept here. Let's be very careful. There is no intercept. I don't know what it is. I didn't give it to you. So I'm gonna pick, this is look like a nice point because this is 2, 2, and this is a 4. That's a good point because it's very clear. Another good point is this one. That's a good point, which is -4, and this is the point that most of you actually picked, and 5. So these are my 2 points. Now what's the slope? Again, 5 minus 4, y2 minus y1, 5 minus 4, divided by -4, that's the x that goes with it, minus, sorry, that's a -2 here, my apology, minus 2. Okay. So it's going to be the slope. It's a 1, -4 plus 2, -2. The slope is -0.5. A lot of you got the slope wrong, and I said I don't know why. So please be very careful. We cannot afford getting that wrong anymore. So that's the slope -0.5. We knew it's going to be negative because the line is falling. So check, does it make sense? So if you get 3, you should know it's wrong because the slope has to be a negative number. Now for the equation, I'm going to pick a point and find it. So I'm going to pick that. I will have y equal -0.5 times the point. I'm going to put -4 too. So here I put the y, and here I put the x value. Okay. So this will give me y -4 will be equal to -0.5. I still have my parentheses because nobody likes -2. So it's going to become x plus 2. Once I make it look nice for me, then I proceed. I'm going to distribute -1. Now I add 4 both sides, which give me -0.5 x plus 3. That's the equation of the line L1. Okay. So please, everyone who did wrong, and a lot of you did, go over your mistake. Ask yourself, what did I do wrong? So you will not do it again. That's the way you learn. All right, so now what does this mean? It means that if I pick an x up to -1, if I pick any x up to -1, and I want to know the point on the graph with this given x, I have just to plug into this formula here. Then I will get the output. So if I want at -1, so suppose this is -1, I want this point. I say, okay, if I put -1 in here, I will have -0.5 times -1, give me 0.5, plus 3, 3.5. So I will know that this point is exactly 3.5. So I have no anymore any difficulties with that. So how I'm going to write my function here? I put a big parenthesis now. F of x is, as long as x is less than -1, to find the output, that's the rule that I need to use. This piece. Now, this is L2. Now L2, the equation for L2 is y equals 3x minus 3. That's the one I did a minute ago, and this one you guys did reasonably well in it. Okay, so I know -3 is my intercept, so I expect a -3 here, and the slope is going to be equal to 3. So it means that if I am between -1 and up to 2, if I want the x, I need to plug it into this equation to find the y. So it's a 3x minus 3. Finally, if x is bigger than 2, and that's the easy part that some of you missed. If x is bigger than 2, that no matter what x is, f of x is 3. This is 3 here. No matter what x is, f of x is 3. So right here, the function is constant. Okay. Now B. So this formula, the idea that this formula and this graph represent the same function. It means that if you take an x and you find f of x using the graph, or you find it using the formula, you should get the exact same thing. So this function is given either like this or this way. So the second question is, evaluate f of minus 6. I want it to be done in 2 ways. One, using the graph, and one using the formula I found. And I should get the same answer. If I don't get the same answer, it means something is, of course, wrong, because this formula represents the graph. So first on the graph, what is f of minus 6? Okay, I go back to my graph. Minus 6 is right here. And f of minus 6. So I go back up here. This is it. So f of minus 6, according to my graph, should be 6. That's the graph. So according to my graph, I get 6. Now what my formula tells me, I should get, as I said, the same answer. According to my formula, if the input is less than minus 1, the output is given by this formula. So according to my formula, I should use this one, minus a half x plus 3. So according to my formula, that's the formula, because that's the equation of the line. It should be minus a half times minus 6 plus 3. Now, this should be 6. If it's not 6, what I'm doing is wrong, period. So it's going to be equal to 6 minus a half times, that's going to give me a 3 plus a 3, which is equal to 6. The values obtained by the graph, the values obtained by the formula are exactly the same. So just 2 ways of representing the same function, the same rule. So these are my comments about the quiz. Now I go back to your questions. Please have your camera on. It's hard to teach only with names. I appreciate very much those who have their camera on. I really would like the others to do it. It's not easy to teach just with a bunch of names in front of you, because I don't see your faces. Which one? Play
My camera cannot turn on. I don't know what's going on.
Okay.
Sorry.
So now I go back to your questions about the inverse, and then we proceed. So let us remember what the inverse is. So when I say f inverse of b, so I have a function f of x. F inverse is basically the number a is the input. That's at f of a equal to b. Okay, so f inverse of b is the input of f that gives me an output of b. Okay, so that's really the definition. So graphically, if I have a graph of a function, so I don't know how it is, the graph of that's a function f. So f inverse of b, it means this is b. F inverse of b is the input that gives me an output of b. That's really the f inverse of b. With this in mind, we go back to each one of your questions. So I have number 8E, 8G. So there is a problem with number 8. So let's do that. So you guys should have the book, and this is my graph. And the question is, just the graph in front of you, and I'm going to put the question. So before I do E and G, which is not very hard, I'm going to do C. What's G of 0? Very quickly. And D. What's G inverse of -3? Just so to get back on track. Okay, so G of 0, so that's my function G. It means this is G, this is 0. G of 0, it's what's the output at 0, which is, okay, it's absolutely 2. What's G inverse of -3? I have an answer. Do you agree with your answer? Yeah. So G inverse of -3, it means -3 now is an output. So G inverse of 3 is the number x, such that G of x is -3. That's really what it is. So I'm looking for the input without -3. This is -3. This is gonna be 1. Okay, so G inverse of 3 minus 3 equal to 1. All right. Now the question that I've been asked is the following. E. It looks complicated, but honestly it's not. If you're told G of -1 equal G of 2 plus K. And the question is, find K. Anyone? So G of -1 equal G of 2 plus K, find K. Okay, I'm getting 5. Anybody else get 5? And of course, where's the 5 coming from? Anybody else? Okay, thanks for those who are putting their camera on. Very few. Okay, I'm having a 4. So I'm having different answers, so we have to clear this up. Okay, how can I clear it up? Okay, what's G of -1? And what's G of 2? Do we know? So I have an unknown K that I need to find. So to find an unknown, I have to ask myself, okay, do I know this one? Do I know this one? So to give me an unknown, I have to, I have to give me something. So what's a G of -1? If this is -1, so this is my x-axis. G of -1 is, it is 0, right? The G of -1, it is 0. So that's a 0. Now, what's G of 2? If this is 2, G of 2 is right here. It's -4 plus K. Okay, so it's going to give me that the K will be equal to 4. Okay, so if they tell me to solve for an unknown K, they have to give me everything else. Otherwise, how can I solve for it? So now let's do F. F is the following, and I'll give you a minute. I'm going to ask one of you to give me the answers, not only the same student. G inverse of -2 equal G inverse of 2 plus J. And the question is, find J. So this is my unknown. If they want me to find it, it means they have to give me the others. Okay, you guys have 1 minute, and then I'm going to pick one of you. Please be ready. Okay. Okay, Zach, do you have any? Zach Wilson, are you with me? Zach?
Yeah, I'm here.
Okay, give me your best shot.
Okay. The G inverse -2 is 0.
Right? Because -2, that's an output value. So -2 is right here. The input that's sent to -2 is 0. Okay, what's the inverse of 2?
-2.
-2. Do you agree with him? Why? So this is my 2. Absolutely correct. Plus J. So what's your J now? Zach? Wilson?
Yeah, 2.
2. End of the problem. Okay, so as I said, it's not as hard as it actually seems to be. Okay, now I look at the other questions from number 15. And the question is, let me back up. 15E. Okay. All right, so we're gonna do 15. I will do one problem before 15E just to refresh your memory, and then we do 15E. Okay, so number 15. The question is now, we need to find a formula for a function. So I have the function f of x, so I'm gonna do number 15. That's what she's asking, 15E. So suppose f of x equal -4 times x plus 2. Okay, and the question is find a formula for f inverse of t. So let us remember what it means. Okay. What does it mean? This is a function, f of x. And if I graph it, just to remind you a little bit what it means, I get a line because as you distribute, I get a line. So it's a line with negative slope. So it's going to get a line something like that. So this is the function f of x equal -4 times x plus 2. Okay, I'm graphing it just to remind you what we are in the process of doing. What does it mean? Find a formula for f inverse of t. It means the following. If I take an output t, can you give me the rule which allows me to find the input? That's really what the question is. So if I know the output, can you find a formula that will give me the input in terms of the output? So let's remember how we do that. It means that find a formula for f t, it means find x such that f of x equal to t. So we want to find the x such that f of x equal to t. To do that, we're going to set f of x equal to t and solve for x. Solve for x in terms of t. It means I know the output. I'm calling it t. This time I'm going to find the input. What is the x whose output is t? I'm going to find a formula for it. Okay, so I will do this problem completely to remind you how it works. So f of x equal to t, it means -4 times x plus 2. So we're going to set this equal to t and solve for x. Means x is my unknown. I'm going to solve it in terms of t. So how can I solve that? What do you think I'm going to do? Quickly. At this stage, you should be with me. Okay, how do you want me to solve for x?
Just, I didn't know if we should get x by itself.
You have to. Whenever you solve, you have to get by itself. Yes. You're going to distribute, as everybody is telling me, absolutely correct. We're going to distribute the -4. It's going to give me -4x -8 is equal to t. By distributing, it's going to become easy to isolate my x. And now what I'm going to do, remember, I'm solving for x. It's x that I need to isolate in terms of t. And now this is going to give me minus, I'm going to add t, both sides. Sorry, I'm going to add 8 because x is my unknown. X is the one I want to isolate. Equal t plus 8. And then I divide by minus 4 across the board. By minus 4. So my function now, the rule f inverse of t, the way we're going to write it is t plus 8 divided by negative 4. So now if I give you t, I give you the output, you can immediately give me the input, whose output is t. So let us a little bit take, I mean, this is the answer to the problem, but let's elaborate a little bit more. So let us elaborate so you understand what this formula given us. Let's elaborate. This is my original function, f of x. This is minus 4 times x plus 2, which is when we distribute, it was that. Okay. So what's the graph? This is a typical linear function. The graph is a line. So to graph it, we need 2 points. The easiest point is the intercept. It means for x equal to 0. I am at minus 8, so I'm going to cheat. This is minus 8 here. And then I can take any other point. So if I take x to be 1, I am at minus 12, which is down here. So this is my line. So this is the graph of, sorry. Okay, so this is the graph of my function. Okay. What does f inverse of t really tell me? Just to elaborate, it's the idea of the following. Suppose I pick here any value. Suppose I pick this to be 10. Okay, so my question is, how can I use the formula to find, what's this? Okay, that's what the formula tells me. If I know the output 10, this formula should tell me the input, where the output is 10. So what is f inverse of 10? According to formula, that if your output of 10, the input is f inverse of 10. It means I'm going to plug 10 into here. 10 plus 8 over minus 4. It means minus 18 over 4. It means if I divide by 2, it means minus 9 half. It means this point here should be minus 9 halves. This point right here. That's what the formula is giving me. So you know the output, the formula gives you the input that gives this as an output. Okay. All right. My question is, how can you check that minus 9 half is a correct answer? How can you check? Just to understand exactly what we're doing. How can you check?
Input minus 9 halves into x.
Right, in the original equation. So if I compute f at minus 9 halves, I'm going to get minus 4 times minus 9 half minus 8. So this will give me minus minus a plus. This will give me 18 minus 8 is 10. And of the problem. And then convince me that, you know, at least my formula is not too bad. My formula makes sense. So that's really what the inverse function is about. All right, so before we move on to the next section, I want to give you one more problem. I wanted to practice it. And then I will assign more of number 15 for next time. So this problem is, we need to find the inverse. And the goal, the reason I'm giving it to you is to practice a little bit algebra. So I'll use this opportunity to strengthen your algebra. So f of x is 3 over x plus 2. The question is, find a formula for f inverse of t. Okay, so I give you 2 minutes to basically set it up, start solving, and then we see what you got. Every student who got an answer, please put it on chat for me. Okay, I'm starting to have answers. I want, of course, more. Uh-oh. All right, more answers. Okay. Just keep giving me. And probably I should do it on the side to see whether you guys are getting it correct or not. So I need more answers. Okay, we're still struggling. All right, so I'm gonna pick one of you and see how the student is basically setting up the problem. Okay, so I'll just pick one as usually in an arbitrary way and see what they did. Okay, let me see. Okay, Brandon, can you tell me what are you doing?
I don't know if this is right, but this is what I did.
Okay,
I tried to take out the division, so I multiplied x plus 2 so I could get it normal.
so first, what's the setup?
So you put f of x equals 3x plus 2. Then you multiply.
Wait, you put 3 over f of x equal to what?
That equals f to t.
Equal t.
Yeah.
Yeah, and what do you have to do? Solve for what?
This is where I kind of got lost.
Right, we have to solve for x.
Yeah.
Let's solve for x. Okay, so in this problem, we assume I know the output t. I want to solve for x in terms of t. And that's, you have to put it in front of you.
Yeah, I was trying to isolate the x and
Very good. How shall we isolate the x? So that's the setup.
that's where I got lost.
Okay, let me see if I can help you. And I know some students are, let me suppose I don't have t, but I know that this t is bothers you. So you guys don't write. Suppose I don't have t and I have, let us see, a number. Instead of t, I have 7. We've done this before. How would we solve that? Brandon, do you have any memory?
I am confused.
Okay, anybody? That's okay, don't worry about it. Just stay with me though. Brianna?
Yeah.
Yeah.
So
How would
what?
you do it?
Multiply by 3.
Both sides?
Yeah,
What's the benefit of it?
because then you
Usually
get
when we do something, we do it for a benefit. What's
get
the
the
benefit of multiplying this by 3 and this by 3?
because you get the x plus 2 by itself.
How?
Because you're getting rid of the division sign by multiplying.
But if I multiply by 3, what will I get? 3 times 3, I will get 9 over x plus 2. Are you with me?
Yeah.
I'm not improving. What is it we should multiply by to improve?
Don't you multiply the x plus 2 to the other side?
Right, we multiply by x plus 2. Why multiplying by x plus 2 move me forward?
Because you're getting rid of the fraction.
Right, so to get rid of x plus 2, what we're going to do is multiply by it, both sides. Multiply by it. Okay, multiplying by 3 gets me nowhere. Multiply by x. Now, what's the benefit? This will go away, and I will have 3 equal 7 times x plus 2, which is more manageable than what we have. Okay, so when we're doing the operation, when we do something, we try to improve on the problem. And now to improve, basically, as you said, we have to get rid of the denominator. So we multiply by x plus 2 both sides. Now I can get rid of it, and then I can do that. At this stage, it's easier for me to start isolating the x. Now I can distribute, and then I can solve for x. So I'm doing a side problem so that when I move to t, I will have minus 11 over 7, and this will be my x. Okay, so it's instead of t, I had 7. So I removed t just so I can work with it as numbers. If I want to get rid of the x plus 2, which is the denominator, I multiply by x plus 2 both sides. This will help me out. So with this hint, can you guys do this question? Brandon, do you think you can reproduce this with a t?
I think so. Just give me a minute after I do my work.
Just talk to the class. You don't have to do it by yourself. Brandon, we're waiting.
Yeah, I'm trying to figure it out.
Okay. Based on what I said, what would you do now?
You would first multiply by x plus 2, get it alone. It would
Okay,
be,
slowly. Get it by x plus 2. What this will give me?
this will give you 3 equals t quotations x plus 2.
Right. Remember, I'm solving for x. Somehow I need to isolate x. What shall I do after that?
First, we gotta finish 3 equals tx plus, oh no, that doesn't isolate it. How do you get that actually?
How do I get this? So I need to distribute.
Yeah, because wouldn't that be stuck as tx though?
No, plus what? Tx
Plus
plus
2t.
2t. I need to distribute. And the goal is to be able to isolate my x. Right, it's going to give me txt multiplied by x. Because x is represent a number and t represent a number. So tx, it means t, you multiply it by x. That's what it really means. Okay.
Okay.
Now, how can I isolate my x again?
You could divide by t.
I can divide by t, but okay, Or you can do what? Remember, x is right here. So how can I isolate the term that has x in it?
You can subtract 2t to the other side.
Yeah, subtract 2t. This will make it much easier. Tx. Okay? And now, what Brandon said, divide by t. Divide by t, and that will give me 3 minus 2t over t. Okay? I said I'm doing this because it's a good algebra problem. That's really why I am after that. So it means f inverse of t is 3 minus 2t, the whole thing divided by t.
I have a quick question.
Go ahead.
So, would you want us to just leave it at that, or could it be like reduced down? Like, could you?
Yes,
Would
it
you
could
be
be
able
reduced
to?
like this. It could be, if you give me this, I will accept it. But since you
Okay.
asked this question, let us see how, if you want, you can reduce it. You don't have to. Since 3 minus 2t, I can split the numerator and rewrite it as 3 over t minus 2t over t. Okay? Which gonna give me 3 over t minus, this t could be simplified, minus 2. There is nothing else we can do. There is nothing else you can do.
Okay, but you would accept either.
I will accept that. I will accept that. Yeah. I mean, as long as you can do all this algebra, I will be actually happy if you get that correctly.
Okay, thank you.
Any other questions? All right, so I'm going to assign more of number 15 for practice next time, and please do them. Please do them. Okay, so today we're going to move to section, what is it? 2.8, I guess, and 2.7. And I will not do them in the details that's in your book. I will actually make them in, I mean, it's an important section, but I will make it more brief than that. Okay, so 2.8, 2.9, quadratic function. Okay. All right, so first, before I talk about quadratic, I have to introduce the word that you should know, concave up and concave down. And concave down graph. Okay. Okay, so far, most of the function we took are linear. I mean, most of the function we took, their graph was a straight line. But a lot of function, definitely, the graph is not a straight line. The graph starts curving. So it curves like this, curve. Now, when a graph curves, it can curve two ways. It can curve, and the curvature is upward. So it can curve upward, like this. Or it can curve, but it can curve downward. So it can curve upward, or it can curve downward. So in the first case, we say here that the graph is concave up when the curvature is up. So it's like this, like a cup, concave up. And in this case, we say the graph is concave down. So very important word about a graph. Another shape of the graph that is sometimes the graph is sometimes concave up and sometimes concave down. So sometimes the graph changes its mind. So it starts curving down, so it's concave down, then change its mind and start being concave up. So at some point it changes. So the graph also can be concave down sometimes, and then it can move concave up. So for example, so in this one, up to here, whatever this point is, that's concave. Concave what up to here, down or up?
Down.
Down. And from here, after that, it's concave up. Okay, so that's the shape. So if the graph is not a line, the graph is, so that's a line. If it's not a line, the graph starts curving. And the way it can curve, it can either curve downward, that's concave down, or it concave upward, that's concave up. So this is the shape of a graph. Okay. Now, what's a quadratic function? So far, we've seen one type of function that we call it linear function. Okay, so far, we only saw what we call linear function. So far, we know linear function. And the linear function had the form. Every linear function is a certain constant, m, we call it the slope, times x to the power 1 plus b. Okay, and the graph was a line. A line, there is no curvature. And the line is up and down when the slope is positive and when the slope is negative. So that's the type of functions we saw. We're going to see for 1, 2, 3 more type of functions before the course ends. So today we're going to see the first one, quadratic. So what's a quadratic function?
I'm sorry, do you mind going back?
I'll go back.
Sorry.
Okay, and this is the B. Since you're taking note, that's always the B. This is when the graph intersects the vertical axis. Are you done?
Yes, thank you.
All right, so quadratic function. Okay. So they are function of the following form. So quadratic function, they are functions where the formula have the following form of the form. F of x equal, so we just see the form first, a constant a times x squared, x to the power 2 plus bx plus c, where a, which is what x squared is multiplied by, is different from 0. So a quadratic function, they are functions that have the following form. And what's important here is that to be quadratic, it means the power here of x is 2. That's what characterizes quadratic versus linear. Linear, the power is 1. Here, the power is 2. So I'm going to give you 3 simple questions. For each of the functions below, decide if, so example, for each of the function below, decide if the function is quadratic, linear, or neither. Just from the shape, decide if the function is quadratic, linear, neither. Okay. Which one it is? All right. I'll give you the first function, f of x equal. The simple one, 2x squared minus 4x plus 3. Okay. Quadratic, linear, neither, quick answers, but those are not hard. Get going, I wanna listen to something. Is it a quadratic function? Is it linear or neither? It's absolutely quadratic because the power is 2. Of x is 2. What's the A? Let's play the role of A. Let's play the role of B. And let's replay the role of C in this function. Okay. So A is what x squared is multiplied by, together with the sign. B is what x is really multiplied by, and C is the constant term. So what is A? Very quickly. So A is 2. What's B? What's B? B is the -4, everything come next to x, and my C is equal to 3. Okay. Now another simple question, again along the same line. Suppose I put f of x equal.
I have a quick question.
I'm just listening. Yeah. Go ahead.
Did you say the b was -4?
Yes.
I thought the b was supposed to be 3.
No, the b is the coefficient of x. Whatever x is multiplied by.
Okay, thank you.
Right? C is the 3. Crucial to know those. Okay, now, question number, so that's my first example. Example number 2. Quadratic, linear, neither. Quickly. Quadratic, linear, neither. All right, any more answers? All right, we're not doing well on this question. Quadratic, the power has to be 2. That's a quadratic. Okay, so that's what matters. So the quadratic, it means the power of x has to be a 2. In this case, the power is 3, that's neither. Those are basically called cubic. So usually they're called cubic function. Cubic because it represents 3 sides, something would have 3 sides. So that's actually called cubic function. Those are not quadratic. All right, so we have to be careful with the power. Okay, so now let me say f of x equal -2x plus 6, quadratic, linear, neither. Very quick. Absolutely linear. So the slope, whenever it's linear, I usually ask about the slope. The slope here is the -2, and the b is whatever happened when x is 0, the b is 6. Okay. One more question, and then we proceed. Suppose I have f of x equal x minus 1, I don't know, x plus 4 times x. Okay, quadratic, linear, neither. Neither. Math, neither because. Math?
I don't think it's neither because if you distribute the x plus 1 to x plus 4, that'll equal a quadratic equation.
Yeah.
And then you multiply another x, it'll turn into a cubic.
Absolutely correct. So that's neither. Okay, neither. Why it's neither? Let's see why he said neither. Because he basically in his head start multiplying those out. So how can I multiply those out? Okay, I multiply those 2, then I multiply by x. Now when I multiply those 2 by each other, I'm going to get x squared, x times x, plus 4x, minus x, it's going to give me 3x, minus 4. But this is timed by x. So when I multiply this by x and I distribute, I'm going to get x cubed. So it's not going to be quadratic anymore. Plus 3x squared minus 4. It's actually cubic, it's not quadratic. Okay, so when you start distributing, because actually I'm going to have x, multiplying the first 2 will give me x squared. When I multiply the result by x, I'm going to have an x cubed. So this is neither quadratic nor linear. This is actually what we call a cubic function. Okay, so that's the shape of quadratic. Our goal is to understand quadratic functions because they come up with us, right? Okay. The simplest type of quadratic functions is the simplest possible type of quadratic function is the following function. F of x equal x squared. Okay, that's the simplest kind of quadratic. What's the A here? What's the B? And what's the C? What's the A? 1. What's the B? What's the B? Don't be afraid of the answer. Yeah, absolutely 0. Because the way you can look at it, it's 0 times x plus 0 if you want. You can think of it this way. The B is 0 and the C equal to 0. So that's really the easiest kind of quadratic function, f of x equal x squared. The other easy kind of quadratic, if you take f of x equal minus x squared. This is another simple quadratic function. Okay, now what we're going to do is we're going to see the graph of quadratic. So today I'm going to do the simplest possible graphs, which basically those with a little bit of addition, and the next time how the whole graph look like. So we have, if the way we can sketch lines, we should be able to sketch those very easily. So graph of basic quadratic function. When I say basic, it means the very simple one. So the question, so graph of the problem. I'm going to do this as a problem, as a question. Okay. I'm going to sketch the graph of the following two functions. Sketch the graph of f of x equal x squared, A, and B. So that's the most basic. G of x, that's another one I'm going to add, x squared plus 2. So I want to sketch the graph of those two on the same axis. Right. So the first one I want to concentrate is f of x equal x squared. That's the one that it has to be like kind of memorized, pure and simple. It's the basic, most simple type of graphs. All right, the way we're going to graph it is really by picking up values and graphing. I will not do anything deeper than that. So this is, I'm going to graph here. And I'm going to graph f of x. So I'm going to take a bunch of values. This is x. And this is f of x. I'm going to plot point and then connect them because I cannot plot every possible value. So I'm going to take, for example, -2, -1, 0, 1, and 2, and find the values. What is f of -2? F is x squared. So f of -2 is, you take -2 and you square it. -2 times -2, give me a 4. -1 squared, give me a 1. 0 is 0. 1 is 1 squared, which is a 1. And 2 is 2 squared, which is a 4. Okay. So definitely all of you know that there is absolute symmetry in the graph. So let us spot them. If x is 0, it's 0. Okay. If x is, so let me put those, 1, 2, I mean, I can put 3 here, -1, -2, and let's see, -3. All right. At -2, I am at 4. 1, 2, 3, 4. So I'm right here. And at 1, I am right here. It's a 0. At 1, I am here. And at 2, I am the total symmetry because I have 4. So -2 and 2, I have 4. -1 and 1, I have 1, total symmetry. Okay. And then at 3, I have 9. -3, I have 9. So if I collect those, I'm going to have this kind of graph. that all of you, I think a lot of you know the name of the graph. Okay, so that's the kind of graph we're going to have. Now let us note that this is not a line by any stretch of the imagination, because when this is increases by 1, we're increasing here by 1. But when we go from here to here by 1, if it were linear, we should go by the same amount. However, from 1 to 4, we're increasing by 3. So this is definitely not a straight line, it's absolutely curving. Okay, so this is the graph of f of x equal x squared. And I'm sure you guys know the graph, the name, this is a parabola. The curvature is up, that's a concave up parabola. Okay, so absolutely have to be memorized, the graph of x equal x squared. So that's a parabola, it's concave up. And this point here, this point where it bottoms up is called the vertex. That has a name and called the vertex of the parabola. Okay, so that's of x equal x squared, important. Now I'm gonna sketch x squared plus 2 next here, and I'm gonna graph it here. Now I'm gonna ask you a question. How do you think the graph of g of x is gonna look like? How do you think the graph g of x is gonna look like? Anybody? Anybody likes to pitch in? Say something.
A square root function?
No, no, no. It
Wait, do you
can't
have
be
that?
a line. Line is wrong because I have x squared. Line has to be x. Okay,
It'd be like a concave down.
no. Let's do it.
It's gonna be concave up, but the values are gonna be increased from the original function
Right, by what? By how much?
by 2.
Exactly. So graphically, what's going to happen? Can you describe it in word?
The graph is gonna be concave up, but it's gonna be more spaced out.
Actually, not spaced out. It's going to be shifted up. Okay, let me explain verbatim what's happening. So let us find values, and I'm going to connect them to f of x. That's why I put them both on the same time. If x is minus 2, now I'm concentrating on g. What is g of x? It's x squared, right? It means minus 2 squared. But what do you do to it? What do you do to it? Please help me out.
Just add 2.
Add 2, which is going to give me a 6. So I'm going to plot this point. This is minus 2. Minus 2. What's the value of g? It's 4, but it was. That's the 4. But what do I do to it? I'm adding 2. So now the g, so I add 2. 1, 2. I'm graphing g now. But I'm going to show you that what's the relation between f and g. I'm really adding 2. From here to here, I'm actually adding 2. It's 4 plus 2. Okay. Now, minus 1. What's g of x? It's minus 1 squared is the x squared, but you're adding 2 to it. It's basically 3. So at minus 1, what's the value of my function? It's 1, basic, but you're adding 2 to it. So this is going to go up by 2. So from here to here, you have 2. But that's my point. That's my g. I'm making the dot for g. What does g takes at 0? Quickly, guys. What's g at 0? It's 0 plus 2. It's equal to 2. So at 0, that's g. So I'm drawing the g graph. So as you realize what's happening, every time the g graph, the graph of the function g is, you're taking the graph of f and you're adding 2 to the output. Whatever the output of f, you're adding 2 to it. So at 1, my g is going to take the value 1 squared plus 2 equal to 3. So this is going to take, so we're going to add right here. That's my g. And for 2, what's going to add is right there. So now if I'm going to connect the graph, it's going to look like this. That's the graph of G. So basically, it's like you take the graph of F, the way it is, and shift it up by 2 units. That's really what you're doing. So what you're doing is, because this piece is the same, that's F of X, so you're adding 2 to the output. You're adding 2 to the output every time. So whatever F takes at X, G is add 2 to the output. So the effect is to shift the graph of F upward by 2 units. So this is the graph of G of X. So it's a shift of the graph of F by 2 units. This point here now is the vertex of G. So the vertex is shifted now. It's not at 0, 0. The vertex is also shifted at 2. Okay? So those are the two basic functions. There are a lot, but those are the ones that I want you to really be able, that was some of the one I want to definitely to know. So x squared, that's the basic one parabola. If you take x squared, you add 2 to it, you basically take x squared and shift it up by 2 units. Now, the second part I would like to discuss, I'll take another, sorry, can I move on? Can I move, yes or no? Okay, if you don't say no, I move. Part 2 is, I want to sketch now, sketch the graph. Sketch the graph of A, f of x equal minus x squared, b, g of x equal minus x squared, let us say plus 2. Okay, the first one is the one I'm interested in. So this one, f of x is x squared. Now I am changing, I'm letting f of x to be minus x squared. And let us see how the graph will be affected. Anybody have any idea how the graph will be affected? Okay, we're gonna do like before, we're gonna pick values and see how the graph looks like. So this is x and this is f of x. Okay, so I'm gonna take the same values, why not? 0, 1, and 2. And then I plot the point. Yeah, it's gonna be concave down. At minus 2, what do we have? It's minus x squared. It's minus 2 squared, it means it's minus 4. So at minus 2, so that's minus 1, that's minus 2. So it is minus 4. So 1, 2, 3, 4, minus 4. So it's going to be right there. At minus 1, I'm going to have minus 1 square. Minus 1 square, so it's going to give me a minus 1. So I'm going to be right there. At 0, it's a 0. At 0, it's a 0. At 1 is minus 1 square, which is a 1. Sorry, it's a minus 1. So at 1, it is, I'm right here. So there is a total symmetry. And finally, at 2, I have minus 4. Minus 4. So the having a minus totally affected the graph. And now this is the graph of minus x squared. That's the graph. So having minus in front of the x squared actually flipped the value. So x squared, so this is x squared. This is x squared. Minus x squared, we basically reflected. We just actually reflected across the x-axis. Okay, and this is the graph of, this is f of x equal minus x squared. So it's also a parabola. It have this shape, it's a parabola. This is a parabola, it means this U shape. So it's also a parabola, but that's a concave down. So it's a parabola, concave down. And what really makes it concave down was having this minus in front of the x squared. Now, if I want g, I know I am out of time, so I will tell you how g is, and I'm going to give you some exercise so you guys can. If I have minus x squared, the same thing, but I'm going to add a 2 to it. So that's a totally new function, which is minus x squared plus 2. How do you think the graph of this new function is going to look like? How do you think the graph of g would look like with respect to the graph? It's going to shift up by 2 units. The graph of g is going to shift up by 2 units because what's happening for g? Whatever f takes, so at minus 2, it's going to be minus 4, but we're going to add 2 to it. It's going to be minus 1, but we're going to add 2 to it. It's going to be 0, we're going to add 2. Minus 1, we're going to add 2. Minus 4, we're going to add 2. So every time I'm going to add 2 to the output. So at minus 2, it's minus 4. I add 2 to it, it's going to put me right here. Minus 4 plus 2 is going to give me minus 2. At minus 1, I'm adding 2 to it. Minus 1, I add 2, it's going to put me here. It's going to put me here. And this will put me back here. So it's just like shifting the graph by 2 unit upward. Okay, so G will be an upward shift by 2 units. So the graph of G is upward shift by 2 units. Okay, so that's really the effect on the graph. All right, so those two are some of the basic functions, quadratic functions. Having the minus in front of x squared made it concave down, fx equal x squared concave up, adding a number here, there is no x here, adding a constant, the effect is to shift up and down the graph. All right, definitely I stopped the class because time is up. Any student with questions?